Hi, we are going to talk a new chapter, mechanics of properties of solids or mechanical properties of solids. Okay, only the basic definitions we are going to see. Then, based on that, we are going to talk or we are going to discuss few problems. Elasticity. First of all, we should know what is called deforming force. In that sense, you take a rubber band, you apply a force in changing the shape of the rubber band. You are stretching it. That force we call it as deforming force. It is changing the shape of the rubber band. So the name deforming force. So the word elasticity means when the deforming force is removed, the body should regain to its original position. When the deforming forces are removed, the body should come back or regain to its original position. That is called elasticity. Rubber is elastic. Rubber band, you can say. See, you cannot stretch it to a maximum extent. There should be a limit. Beyond the limit, if you stretch or give a force, the so-called deforming force, the body will break. That means what? That is called elastic limit. Within the elastic limit, you have to apply a force. So it should not exceed the elastic limit. That is the basic concept in elasticity. Plasticity. Plasticity. When the deforming forces are removed, the body will not come back to its original position. That is called plasticity. The body will not come back. In that sense, you take a plastic bowl, you apply a force. To some extent, it is circular in shape. When you stretch on two sides, it will become oval. When you remove the deforming force, it will contract to some distance, then it will stop. The perfect shape of the circular shape has gone now. Sir, I will apply a force in the opposite direction to compress it, or on the other two sides I am putting, the diameter will increase now. The body will not regain the original position. That is called plasticity. Elasticity is different, plasticity is different. So when the deforming force is removed, the body regains to its original position. You call it as elasticity. When the elastic force is removed, the body does not regain to its original position. We call it as plasticity. Okay, simple. Stress. Stress is nothing but a force. Force applied to a given area. So force by area only we call it as stress. This is otherwise known as pressure. Force per unit area is called pressure, you know. So this is otherwise known as pressure. Stress is a deforming force applied to a body for a given area. Stress is equal to force by area. Unit wise, Newton per meter square. Dimensional formula of stress. This is force ml t power minus 2 by area L square, cancel, m L power minus 1 t power minus 2. ml power minus 1 t power minus 2 is the dimensional formula for stress. Okay. Strain. Change in dimension by original dimension, we call it as strain. Change in dimension by original dimension. Dimension in the sense, it might be change in length by original length, change in area by original area, or change in volume by original volume. Anything you can take. So strain, change in dimension by original dimension. So change in dimension, the original dimension, the word here means change in length by original length, or change in area by original area, or change in volume by original volume. So unit of numerator and denominator both are same. Unit in numerator and denominator same means what is the meaning? There is no unit for strain. Strain has no unit, it is a ratio. So no unit for strain. Okay? Fine. Next. Hooke's law. Hooke's law. Within the elastic limit, the ratio of stress and strain, or stress by strain, is a constant. Stress by strain is equal to constant. First condition, within the elastic limit. This possibility is stress proportional to strain, or strain experienced by the body proportional to stress. So when you draw a graph, stress versus strain, as stress increases, strain also increases. Up to a particular point, then the body will break the plasticity concept. Only this point, this region, we call it as elastic limit or elastic region. The strain produced by the body is proportional to the stress. Strain by stress or stress by strain, both are same. Ratio is a constant. Because of the application of the force, only strain is produced. So strain proportional to stress. So this is Hooke's law. Basic concept here, within the elastic limit. Stress by strain is a constant. Basic concept. Correct, no? Fine. Next. This stress by strain unit, denominator strain has no unit. Only stress has got a unit. Denominator strain, no unit at all. So I can say unit of stress is unit of, this is called elasticity. Modulus of elasticity. Stress by strain is equal to a constant is called modulus of elasticity. This modulus of elasticity we call it as, it is a constant. Unit is unit of stress only, Newton per meter square, because denominator strain has no unit. So this modulus of elasticity divided into three different concepts. Young's modulus represented by Y. You take a wire. Wire is suspended from the top. When you take a wire, you apply a force. Apply a force. End of the wire, you apply a load. 1 kg, 2 kg, 5 kg, you apply a load. The steel, if it is a steel wire, it will stretch to a bit. How much stretch is taking place, that we have to calculate. What is the force you are giving to that particular wire? Area of the wire is pi r square. So, Young's modulus is longitudinal stress by longitudinal strain. That is linear stress by linear strain. Linear, longitudinal, both are same, representing the length. Linear stress, force by area, divided by change in length by original length. Initially we have 1 meter wire. You are applying a force or you are suspending it by pulling it by a weight of 2 kilogram. You are applying a mass 2 kilogram. It is stretched by 5 millimeter. That 5 millimeter divided by the total length 1 meter, we call it as strain. Okay. So I can write L will go to numerator, F into L by A into delta L. FL by A delta L. We call it as Young's modulus of the wire. Same unit, Newton per meter square, otherwise known as Pascal. Newton per meter square or Pascal. Pressure unit. Next term. Bulk modulus. Represented by K. You see the word itself, bulk. Bulk means the total volume. So I can say you are applying a force on all the sides. Thereby the body is compressed. So I can say bulk modulus is inversely proportional to compressibility. Compressibility is inversely proportional to bulk modulus. So K is equal to bulk stress by bulk strain. Bulk stress by bulk strain. Again, what is bulk stress? K is equal to force by area divided by bulk strain, change in volume by original volume, delta V by V, change in volume by original volume. Here we are going to put a negative sign. Why negative sign, sir? When you apply a force, the body is compressed. So bulk modulus is inversely proportional to compressibility. For that we are putting a negative sign. So minus F into V by A into delta. This is bulk modulus. Next is rigidity modulus. Some books it is given as capital N as rigidity modulus. Some books they are given as eta, rigidity modulus. We will take it as capital N. Shearing stress by shearing strain. What is called shearing strain? Angle of shear, shearing strain otherwise known as angle of shear. What is called shearing stress, shearing strain, that and all. You take a box, hollow box, which is fixed at the bottom. Here it is fixed. Now you are applying a force. Here as well as here you are applying a force. When you apply a force, since the bottom portion is fixed, what is happening? Slightly it is moving. Theta. This portion is fixed, it is not moving. So it is fixed. So N is equal to shearing stress, same concept, force by area. Shearing strain, that is angle of shear, that is theta. So I can write F by A theta is called rigidity modulus. Sir, shearing strain, whether it is linear strain or volume strain, bulk strain or shearing strain, it is a ratio. But here you have put only theta. Actually it is tan theta. Tan theta means opposite by adjacent. Opposite side by adjacent side. When tan theta is sin theta by cos theta. Tan theta is equal to sin theta by cos theta. When theta is small, sin theta is equal to theta, cos theta is 1. So tan theta has become theta now, that's only we have done. So this is tan theta, this is a ratio, opposite side by adjacent side, it is a ratio. Okay, so this is called shearing strain. So we have studied elasticity, plasticity, what is called Hooke's law, then very important factor, stress and strain. Based on that we have seen Hooke's law. In Hooke's law the very important point we have to consider is what? Elastic limit. Within the elastic limit, that concept you have to tell. Then stress by strain is a constant, is called modulus of elasticity. 3 modulus of elasticity here we have. Young's modulus, bulk modulus, rigidity modulus. Young's modulus, linear stress by linear strain. Bulk modulus, bulk stress by bulk strain. Rigidity modulus, shearing stress by shearing strain. Shearing stress by shearing strain. Okay. Then we have seen the basic formula of all these 3 factors. Very important factor in bulk modulus we have seen compressibility is inversely proportional to bulk modulus. Sigma compressibility, sigma is 1 by k, compressibility sigma is 1 by k. Then Poisson's ratio. Poisson's ratio. What is the mean? It is of the rate. That means it is a number, no unit. Again, sir, you have a wire. Here you are applying a load. When you apply a load, the wire is stretched. That means, take it as rho, Poisson's ratio rho. When it is stretched, lengthwise it is stretched. The length increases, whereas the diameter decreases. So, the Poisson's ratio formula is Poisson's ratio, lateral strain, ratio of lateral strain to the longitudinal strain. Ratio of lateral strain to the longitudinal strain, we call it as Poisson's ratio. We have some experiment to prove the Poisson's ratio. While doing the problem, we will explain that one. Okay, fine. We will continue the problems. The next part of this mechanics or mechanical properties of solids, we are going to see few problems related to the theory what we have discussed. One by one we will see.